Objective 7. Use order of operations to make predictions. Example, in 2000, about 16 million people graduated from college. This number has been steadily increasing every year since 2000, with an increase of about 0.5 million students per year. In Part A, complete the table below to help find an expression that stands for the number of college students graduating at T since 2000. So we have our two columns. The first one is T years since 2000. So this is 0, which would be 2000, 2001, 2002, 2003, 2004, and then the year of T. And then the number of college graduates in millions. So we know that in the year 2000, which is 0 here, we know that there were 16 million people graduated from college. Now, we know that it increases at 0.5 million students per year, so when it goes from 2000 to 2001, 16 plus 0.5 is equal to 16.5. Now, to go from 2001 to 2002, now we're increasing in another 0.5 million. So 16 plus 0.5 plus 0.5 is the same thing as 16 plus 0.5 times 2, which is equal to 17. Then we have 2003. So 16 plus 0.5 plus 0.5 plus 0.5 is the same thing as 16 plus 0.5 times 3, which gives us a result of 17.5. And then in 2004, we have 16 plus 0.5 times 4, which gives us a result of 18. So what would this expression look like? Well, if you notice that if we're looking at T, meaning the years, we're taking 16 and then we're adding 0.5 times whatever T is, depending on what that year is. So in Part B, then we can answer the question using this expression. So we're going to evaluate the expression found in Part A for when T is equal to 15. And so what does the result mean in this situation? So we'd have 16 plus 0.5 times T, which is 15. So 15 times 0.5 plus 16 gives us 23.5. So 15 years, or 2000 plus 15, gives you 2015. So in the year 2015, there were 23.5 million college graduates. Another example. It says in 2010, the number of HIV deaths in the United States was about 15,000. Since 2010, the number has been steadily decreasing by about 1,200 every year. In Part A, we want to complete the table below to help find an expression that stands for the number of HIV deaths in the U.S. at T years since 2010. So here's your first column, and then here's your second column. First column are the years since 2010. Second column are the number of HIV deaths in the U.S. So at 0, we know it's 15,000 minus 1,200 times 0, which means there were 15,000 HIV deaths in 2010. And then 2011, we have 15,000 minus 12 times 1 because we've increased it to 1, so 1,200 times 1. So 15,000 minus 1,200 gives us 13,800. Likewise, 2 years since 2010 is going to be 15,000 minus 1,200 times 2, which is equal to 12,600. In year 3, 15,000 minus 1,200 times 3, which is equal to 11,400. And in year 4, we would have 15,000 minus 1,200 times 4, which is equal to 10,200. And in year T, it would be 15,000 minus 1,200 T, and therefore that is the expression that stands for the number of HIV deaths in the U.S. at T years since 2010. Now for Part B, it says evaluate the expression found in Part A for when T is equal to 5. And then what does the result mean in this situation? So plugging in T to be 5, it's going to be 15,000 minus 1,200 times 5, which is equal to 9,000. So 5 years have passed since 2010, which makes this the year 2015. So we would say that in 2015, there were 9,000 HIV deaths.